Okay, so let's get started. First thing we're going to do is we're going to create a data server connection, and we'll create the weather one first. And the weather company connections are pretty simple. I'm just going to leave it at that. JDBC colon TWC colon whack whack. And that's going to be about it. I don't need to do anything else. The ID that I'm going to use can be any ID, any old ID that I want. However, the password is going to be the API key that I've purchased through the subscription to the weather company. Unlike Mapbox, the weather company subscriptions are not free. Let's just prompt for the user ID and the password. Let's call this any user. Paste in my password. Admit it. I want to save it. Okay. But I want to create a sign-on because as I'm making calls, I don't want to be prompted every single time. So let's create a sign-on here. Call this TWC sign. Passwords match. Save it. Test it. I need to save this. We'll call this their demo for user group. Okay. Now that I've got my sign-on, I've got the connection details. I need to bring in the various schemas. I've got forecast available to me. I've got historical data available to me. The level of granularity that we have available is at lat long, but it also is at a postal code. And the postal code is going to be important because by itself, the weather API does require filters on the data for the data to be returned. I can't just bring in the table from the forecast or from the historical schema and have it just return everything to me and I just scroll and scroll and scroll. I do have to have filters. When I bring this into a data module, you'll see how I do that. So let's just bring in, I'm going to bring in system because it'll give you an idea of what fields are available to me and what the format has to be. And I don't want to retrieve samples. I want everything. I also want geography because it'll give me an idea of what the format is for postal code because there is a specific format that it is looking for. That. And then let's grab historical. And those are about done. Once those are done, we'll create our data module. We'll also pull in an Excel file that I'm going to use to join up that's going to serve as my filter. Now, I could have prompts. I could have those filters just baked into the data module, but I'm going to use Excel to provide them. Weather demo user group. And let's bring in historical schema. Let's start with that. Now, what you'll see here for weather is you've got all products, which is a combination of all of the dew point observations, the feels like observations, the wind gust observations, and even by themselves, each one of these products, the dew point product has a ton of different observations. So under all products, I'm going to see everything. And honestly, that's just way too much. So I'm just going to grab temperature, which I think is going to have everything that I need. Precipitation, depending on the time of the year. If it's seasonal, that might be pretty helpful, especially if I'm looking forward-looking. If snow or inclement weather might be important. I don't know about where you guys are, but Halloween last year, we had a whole bunch of snow here in South Central Wisconsin, and it was honestly no fun. I'll bring in that table, and I get no results, as I said before, because there are no filters on this. We have to apply filters, and we're going to do that with a join in just a second. I do want to add another source. Go to our weather demo UG, and let's just bring in geography, and that's going to give us the format that all of our locations have to be in. Now, I'm not going to join this table to anything. This thing is just, this table is just informational to me only. But I can see that the postal key looks like it's a zip code, colon, and then the country code. So let's just create a quick filter. Search for US. Those are the zip codes that I'm going to be using because those are in my file. Now I've got something that looks a bit more familiar. I've got latitude, longitude, postal key, the postal code. All right, so this is starting to look good. Let me just save this quickly. And where do I think there's a weather company? There we go. User group DM. All right, let's save that. Now I'm going to bring in the Excel file that has I think the top 10 cities for, I think they either use population or population density. So I'm going to blend in weather with population density, density per square foot, total population, that type of thing. So let's grab another source. Grab this from our weather folder. US postal codes TWC. And again, this is what I uploaded. I created this a couple of weeks ago. Let's bring this in, select the tables we want, and we want top 10 cities. Now, just for grins, let's have a look at top 10 cities to see what it looks like. I've got a postal key, a postal code, a place name, which is the city, state, the abbreviated state, population, square mile density, and the date. This is going to be important. When the API calls are made to through the weather API, it's on a zip code or postal key basis and also by a day basis. So as you can imagine, if you pull in 2 years worth of data for, let's say, 400 or 500 different postal codes, that can be a heck of a lot of data with any given call. Now, admittedly, I have seen some customers who have subscriptions to the weather data, and since historical data doesn't change, it is what it is. The observations are what they are. I have seen clients take snapshots of weather data and store it in their data warehouse because then they can manage it, and they've paid for the subscription, they've paid for the service, so I believe they can rightfully do that. But that's one option to create what I'll say a running total of dates and locales for which you want to get historical data. Rhea, are you seeing any questions in the chat?
There was a question, but I got answered.
Oh, okay, good. Thank you. Okay, the top 10 cities is going to serve as our filter for the temperature table. Let's join these together. Got postal key and postal key on the temperature side. You can see no data available. Again, I haven't filtered it yet. Let's match those. I'm also going to filter on date because I want the date range that I've got in my Excel file that's going to limit the days that I want those observations to come back from the API call. I want those to be in effect in place when that call is made. We'll match those, and I can see I've got two matched columns: postal key equals postal key, date equals date. Inner join 1-to-1 and unique range of values. Let's see if this is going to work for us. All right, good. So now I've got data from, looks like I've got data from my Excel file. So I've got postal code, the place name, the state, square miles, my matched columns, postal key and date, latitude, longitude, and now I've got all of my temperature data. Now, the good news is, or the bad news is, all of the temperature observations are in kelvins. I can't do anything with kelvins. However, I can create a custom calculation that allows me to convert kelvins to the temperature. So let me do that. I'm going to create a custom calculation in temperature because that's where I want it to be. And the calculation to convert temperature or kelvins to Fahrenheit in this instance is the temperature times 9/5 divided times or plus 32. Clear as mud. Let's create a new calculation. Here we go. And we'll call this Av temp Fahrenheit. Daytime average. So I'll paste in temperature local day average. I happen to have gotten that temperature local daytime average minus 273.15 times 9/5, and then take all that plus 30. Now, since I haven't made a call using the weather API yet, if I check or validate this formula, I'm not going to get any results back. But what we can do, once the formula is created, is I can go to the join properties and I can refresh it. And let's see what we get here. All right, much better. The local average is 295 kelvins and it's about 75.5 degrees. That's something that makes a whole lot more sense for me, especially in Yonkers, New York, around July 1st. So now it's starting to get to something that I can actually use. Okay, questions so far?
No questions.
All right, the next thing I'm going to do is I'm going to create a REST connection. Again, REST is an open source connection-based method that allows you to connect to an endpoint that is listening as or accepts REST-based connections. And more, what I think we're seeing is whether it's databases or web services, even some of our competitor products, where people might want to connect an IBM product to a competitor-based product, and REST is the way that we're being asked, IBM is being asked to connect to our competitor. We just have to be flexible. So let's create that REST-based connection. And the connection type that we've chosen, there are a number of different, as I understand it, that we were evaluating, a number of different REST-based methods. We settled on the progress direct REST-based connection. So I've got my connection parameters here. And the website that I'm using, or the connection that I'm using, it's from the sportsdb.com. If I were to take and copy this and paste this just in a browser, which REST supports, I get something that's pretty ugly. So let me move it into Firefox, which is a bit more flexible. Organizing this. So there we go. So I've got JSON. I'll expand it all. And this is essentially the response back from the REST call. This is what the looks like from a browser, but what I'm going to do is I'm going to render this in a REST response back from this website into a Cognos Analytics data module so that I can blend it in with my dashboard. Now, this particular website accepts REST calls. It accepts anonymous REST calls. If you subscribe to a service or you have a database or a REST-based connection that requires an ID and a password, you would create that sign-on and generally connect through it through the convention. Let's test that. If it succeeds, we'll save it. New name, did it not save it? I hope I don't have to do that again. Okay, looks like we did. Okay, so let's do that quickly. That's not it. Let me grab the website, grab the connection details. Must be changed from the phone. Do that. Let's call this L. That. All right, let's call this NFL demo. There we go. Okay, good. Now let's go back into our game module. Our weather stuff. Let's go to add new sources. Go to NFL demo. And did we load a schema? We did not load a schema. Always load your schemas. Go to NFL demo. Connections. Schemas. There we go. And I believe the schema that we want to load is
Jason, we can't hear you again.
Oh, is this better?
Yes.
All right, sorry. Let's load auto rest. I don't think we need information. I don't think we need public, and we certainly don't need the. How are we doing? Can you hear me?
No, we couldn't hear you.
Oh, how are we doing for time?
We got about 10 minutes left.
All right. Should be easy enough to finish in that time frame. Demo. There we go. Schema, what tables are there? There we go. So this is going to have a lot of helpful information for data that we want to bring in. So let's just have a look at all of our team stuff. It's got everything for the NFL. So I've got stuff for the Arizona Cardinals. So all 32 teams are now going to be in here. Their name, their website. They've got some social media, social media information in there. They've got stadium. I'm going to create a dashboard that brings in some of this, talk about stadium capacity. So we'll save this, and now it's time to bring in this data into a dashboard. And while this saves, what I've seen a lot of clients do is mash up especially the weather data in with predictive-based forecasting or even strategic planning as a way to plan for workforce, as a plan for for clients, for space planning. It's the number of use cases are really endless, and it's just a critically important asset to have when doing your planning and doing your strategic forecasting. Let's create a dashboard. 2x2. I'm going to take advantage of the maps that are here in Cognos Analytics. Grab a map, drop that here. And let's grab top 10 cities. And in region, we want to, I think we'll put in state. Population. Okay, that looks good so far. So at least for the areas, we want to make this average because there aren't 247 million people who live in Texas. Oops. So let's make this average population, summarize average. All right, much better. So for the observed areas in Texas for this data set, what I'm looking at is an average population of about 1. All right, for points, there. Let's grab state abbreviation. And let's see if we can bring in place name. So here we've got our locations, places in Texas, Dallas, Houston, Chicago. I think these were the top 10 cities that I selected as a part of this data set. But now let's grab the weather stuff. We'll grab average temperature. Point size. Let's try point color too. Okay, now things are really starting to take shape. Let's add date to a list, table rather, and we'll add date to this because date's going to be really important. Here's my date range from July 1st all the way to August 17th. So let's see how the temperature fluctuates. July 1st, average temp is about 90 degrees in Phoenix, still pretty hot, 86.8. But in New York, Yonkers, it's only about 70 degrees. But let's fast forward to the dog days of summer, August 16th, just before kids are going back to school. We're now at a temperature of 101. And temperatures have also risen significantly in other parts of the country. All right, so we brought in dates, we brought in weather. Now let's bring in something from our REST-based source. And this is our REST stuff. We can bring in a word cloud. What I think I'm going to do is now show the stadiums, which will mean the words. Stadium location, and then stadium capacity. All right, so I get an error here. And what Cognos Analytics is going to try to do is it's going to assume that the data that I bring in from a data module, all of the tables are joined. But in this instance, I know that the weather data is not joined with the NFL data. Let's break that apart. Okay, good. So I've now broken that apart, and now I've separated the weather data in the map and in the list of dates. So that's still responsive, but I've left the NFL stuff that I brought in through my REST connection in place. Now, if I wanted to join those, maybe I join them on state or postal code. if I've got postal code available to me in the REST-based data. And at that point, I've got one-to-one, and now I've got something that I can filter on by date.